Hi, everybody. Thank you so much for joining me to this presentation. I'm going to be talking about PLC libraries for detecting abnormalities. So what we are going to see today is why it is important to have it in the detection at the plant level, and then the difference between the security alarms and also operational and safety alarms, and what we don't want to mix up them and then make the operators confused. So we are going to create also using built-in PLC, so use what you already have in the PLC. And then from there, we create a detection library. So we are creating several blocks that are going together to create this library. And then we have the library categories and how we display the alarms in the HMI. So how this idea came from? It came from actually 1 year ago when I was about to join Dragos. During my interview, my boss asked me about the key switch, if I know how to detect that. I didn't really know it, so I get so frustrated, and after that I went to my peers and I started asking them if they actually do that. So most of them, or I think all of them, told me that this is something that automation engineers really, we don't do it, but we do diagnostics. So the diagnostics that we normally do is for I/O modules, and also to do the communication between the PLCs and other stuff for the processors. So I joined Alejandro Cadena and also Mike Hoffman, so they are my mentors, one in control, another in security, and then we realized that we can pick three things. So the main things were like safety logic is first, process and safety logic is our priority. Then we want to have also alarms for security, safety, and process. And then we have also the standard, so use what you have. So the PLC has already a lot of things in there that you can use it. And of course, to provide visibility for awareness to the lower controls, to make the operations also to be aware of some other incidents that they can have. So what it is important to have in the field the detection? It is because the operations are our eyes in the plant, they are the hands in the plant, so they will know when things are changing, when things, if there is a maintenance, if there is if there is a stop in the plant. So if they see like there is a download in the PLC, they will know actually if the download is because it is a job doing or if it is something else. And of course, we want to introduce them to the incident so they can also be aware of what they can do. And because they do it with maintenance, so if they see that one switch is not working, they call maintenance immediately because they have those alarms integrated. So with that, they will have also alarms that they can help the incident responders and so on to be aware of the events. And then what is the difference? So we have safety, operation, and security. So please don't mix up all those alarms, because being in the plant and then seeing a lot of alarms just popping up, suddenly the operators will not be interested in take care of those alarms. So we have safety, operation, and security. So safety is mainly to mitigate the hazards, and then operation will inform the deviations in the process. And security is, as you all know, is integrity of the system. So here are just examples. So if you have safety, for example, then means that you can have a e-stop activated. So if you see, like, for example, in a line, in a process line, it's not working on something like that, you will see, like, I'm sorry. So the first thing that you will see is the e-stop activated. That means that somebody pressed the push button. And then we have also high level, valve opening, or high pressure, and then that is when the seize is coming. And also we have operation that, for example, we have open fault. That means that somebody is moving the arm, or it's moving some kind of valve, and then you have a timeout. So that is not security. It could be just like the sensor should move, or the valve is just lockout. So we have a block that it integrates several events that you can then integrate it to the security. I will explain that later. So we have, for example, for security, we create a block to detect the Setpoint Delta, and then also, of course, the key switch and range manipulation and other alarms. So how do you detect that? Using what you have already in the PLC. We use Rockwell because it was a PLC that I have handy, and I use version 20 in this case. And we were using the get system value, message, audit value, and regular functions. So the get system value is mainly as a function that it brings all the status bits to get the data processor, and then do the diagnostics. We have the message, and that is to get the memory data from the processor. It creates also logs, and it also that function we use it for integrating but for communicating different PLCs, different brands of PLCs. And then we have the audit value. So the audit value is actually a built-in function in Rockwell that it detects download changes, it detects also the key switch, it detects several things and then put it in a log. But that one, it changed depending on the version. So version 20 is kind of old, and sometimes you have to work a little bit around. And then we have the regular functions. So the regular functions are like very easy logic, it's comparisons, additions. You will see that I just have contacts, coils, that's it, what I have. So, and of course, each platform is different. So Siemens, for example, handles SFVs, SFCs that are similar to the get system values. So this is what we have in the library. This is one block. This is actually for the key switch. So the first thing that you have to think when you are designing those blocks is the parameters. What do you want your engineer to parameterize? It's very important that you don't put like a lot of information for them to parameterize, because it's when errors come. So in this case, we create just like tags. The tags was the first one, and you can create also like the limits, parameter, things like that. And then use the main function, the get system value, the message, what you have already. And then play around with what you are getting from there to trigger the alarms. And as you can see, it's a very simple logic. There is nothing special here. It's just normal contact opens and close opening. And then we have also internal tags. So the internal tags are the ones that you don't want to put it outside of the logic. That one is integrated in your block. So that one is because you don't want that information to be manipulated. It's actually your logic. And then we have your HMI, your alarms. What are you gonna trigger in the HMI? And this is what the result. So you don't have like a big logic. This is not something that it will affect your memory. So why do we have embedded logic and what we use it? Normally we use it as automation engineers. We are not like creating all the time the logic. We actually create libraries and we use that and we just improve the logic that we have it. So the thing is in Rockwell, the main thing is that you cannot change the AOIs when you are running online. And also in Siemens, the FBs are complete protected, so you can protect those. And the logic is, so you can use also a sourcing protection. That sourcing protection will give you, you just put it in a text file, and that text file is saved, and it creates some kind of key. And then it can be easily imported. So you just have to create that block, export it from your project, import it to the other project, and then the only thing that you have to change are the parameters and also the tag. That's it. You don't need to create all the logic and then change a lot of logic and a lot of parameters and a lot of tags that are embedded inside of that. So, and then you have when you create a library, it means that you have already tested that. So it's not that you are going to be on site testing that kind of stuff and making the life difficult for the automation engineers. So we have to think about them as well. So what is the library classification that we create? So we have the security functions, and we create it in 3 phases: controller performance, and we have the operation, and we have also what is the risk of misabuse. And inside of that, we have a security handlers. So the security handlers are actually the ones that are monitoring and are creating security for the security functions. And also we have developed in the security handlers a block that it is a multiplexer, and that block is creating the events. You can create events inside of that one. And then from there, we don't just want to have it we just don't want it to have it in the PLC and HMI. We want also to send it to ACM, to another IDS that have more tools, more capabilities that you can do analysis and things like that. So we create a socket in the PLC, and from there, we take the information as Excel or text. So this is what we have. So we have the controller performance, and this is the 3 blocks that we are creating. And those are the ones that you created as a set baseline when you finish your project. So you have to create what is the memory that you have already, what are the Ethernet objects that you have to that PLC, and also you have the scanning cycle. So, for example, the memory usage, it is this one, it's mentioned in the top 20. They are checking the trends and then comparing it and putting in the HMI. In this case, it's a good idea, but we created also an alarm for that. So if you are beyond that memory, then you create your alarm, and then the operators will know it's just an alarm. They don't have to be checking something else. I'm sorry. And then we have the program execution. So the active connections is a block that it's gonna call from zip the connections that you already have. We are testing some of the blocks, so I'm not showing all of them, but we are publishing a paper, and also we are working in a blog where we are explaining all of those. And then we have the program execution. So the program execution is basically when we want to detect if there is a change in the logic. And this is done according on what the changes on the scan cycle. So we actually detected a change, but what we see, it was when you go to lower scan cycles, it's very difficult. So what I'm showing here is actually how do you detect. We are in 300, 400 microseconds detecting. So as you can see, you cannot see anything. So what we did, we create just a filter for 200 milliseconds. So we have a better explanation of here, and then we create a full logic, and then we import it, and once we import it and then execute the logic, we detect this high peak. So that means there is a change. That was good, we have that. But we are engineers, we have to test more things. So what we did, we create a small logic after what it is calling it, and then that is when we see the issue. We didn't see anything in here. So 200 milliseconds is not enough. We cannot just create like a basic filter here. So what are we proposing in this case is to use a lead lag. And then the lead will be used to use the amplitude, and the lag is gonna be to check the frequency. Once having that, then you can compare and then do a set baseline to have both, and then we can compare to have the changes if it is minimal or not. And also, we want to have it also in the very low scan cycles. This one is still under construction. We are testing that one. So we have the process operation. So the process operation, actually, we have 2 blocks. Those 2 blocks are for limits and are also for Setpoint Delta. This one you can integrate it to the process, but it is going to be for security. In this case, what we created is we have a profile for the electric furnace, so we have to have hard-coded those limits. That is something that it's also mentioned in the top 20. You can see that they will tell you you have to hard-code it, so if you are not doing it, it's like, okay, so. What we have here is like you have the block of those limits, and then the sec lim is actually our block. That block locks since the beginning that limitation. So, and once if the adversary comes and change those values, then it's when we trigger an alarm. And then we have the use case for the Setpoint Delta, and in this case, you can use it also for process to check where is your calculation, and also it can be checked if somebody is changing that value. So we have an array to select that one, to select what is the next profile after the hit is coming. So in this case, we have a set point and base set point 1, and also this block have a selector that it will detect if it is the base set point will change or not. Those selections, those parameterization are also locked. So in here, in case, for example, but not the difference. So the difference should be always the one that you are setting. In this case, if you have one, so we wanted to go one by one in each of the arrays. So you go for 1. In this case, we have an example of hit 6. The next hits will be 7. If it is 8, then is when we'll trigger that alarm in here. So, and then it will change the new set point value. You have to go back to get rid of those alarms. And then we have the risk misabuse. We have the key switch detection, of course. There is the GSB plus the status bits. And then we have a program firmware. This one, we actually use it with another PLC. It was a click PLC. So we get the information, we send the information to the click. The click is saving that value and send it back to this PLC. And then this PLC is the one that it is going to be triggering the alarm if it doesn't detect the same as the click. And then we have the program download online changes that we are using the audit value, and also, as I mentioned before, it is on the top 20, and you can use it directly as it is. It will create a hash, and that hash you can log it, and then you see that in the analysis. And also in the new versions of Rockwell, they have some kind of tracking, but in the old versions, you don't have that. So what we are creating is to put value, you don't detect everything, but at least you detect the download and the change, playing with those bits, with the bits that you see from the status. Or you can use the performance controller and functions by the memory and also the scan cycle changing. So we have the security handlers. So the security handlers, we have the function monitoring, the initialization parameters. So the initialization parameters are actually the ones that locked. The security functions monitoring is the one that is changing everything. And then we have the events. So the events is actually the one that you select what are the different events that you can put it in there, and then it will create the alarms. And here is how it is programmed. So you have in your 100 milliseconds, you have your delta block, and also you have the monitoring. So the monitoring block, because it is a security block, we put it in a 10 milliseconds task, and that one is sending the heartbeat also to the click. So that one is monitoring between the blocks. And then we have the main task. So the main task, the key switch is the only one that it has to be in the main task, because the program is not detected in other cycle task. And from there, you have the same thing. It goes to the monitoring, and then we create the alarms if you lose that one. And this is the log that we are creating and sending to the others. And this is the demo. So this is the lab that I used it, and it was just with a click and then a PLC. And then, can we start the demo? Can we play the demo? Okay. No. Let me go back. Okay, so it's coming. So I create two banners to show what is the difference between the process and the security, and here is the logic. So we have a valve and a heater, and we have also the control for the level, and we use a PNID in this case to show the alarm. And we have the memory that it is displaying here, and then we have also the key switch local and also the firmware that we are reading. So, and this is the same thing that I showed you before. And then we have here the key switch. As I told you, you cannot put it in a task, so we are using the main task. And then this is the logic that it is representing. How do you put it together? And now that is what we do. So we have a difference here in the block that it is 10, and your set point base is 10. So if you change it to 5, we will not have any alarm because you are inside of that range. And now I'm going to be changing that to 15. And then those 15 is still inside of the range, so it's not going to create any alarm, of course, because we're still inside of the range. So now we want to change to the 25, and then the alarm will come. So that means that there is a difference in your set point, and it's when the alarm came. And that means that because normally you work in certain range, but you need to have also another range because normally the operations can work in another. There are two ways that you can get rid of that alarm. One is going back to your range that you should be working, or the other one is that you have an acknowledge in another screen that will change the set point base. In the use case that I showed you before, they don't have, that selector is inside of the block, so you don't have to be acknowledging that. Right now, I'm changing just to 5, just to demonstrate that there is no alarm. We get rid of the alarm again, and I'm changing to 50 again, and this one will trigger the alarm, and then we want to get rid of the alarm, but the operator wants to work in that range, so he wants to work from 50 to 60, 50 to 40. So he will accept the set point, and then will trigger that we don't need that alarm anymore. So if you go back to the 5, you will see the same thing. So now I'm changing to 5 again, and then the alarm is coming because we are in a new set point value. Now we were back to 55. We are inside in the new set point base, and then we got So now we are going to talk about the hysteresis loop that I have here, and this is for the limits. Those limits are already logged. That is the flash bit that we created, and this one will log the value. So that means that you cannot change it anymore, so you have to create another tag. But first of all, I need to change it from the remote. So I'm testing the key switch block, and this is what we got. So we have a sensor, and then we have the limitations here. We have the status. So coming from the block. And then we have the program. Once I change it to remote, then we trigger the alarm that the key switch has changed to remote. And now I have to change it again to program just to demonstrate that this block is working. So that's what I'm doing now. So I just changed it to local remote, and then as you can see, to program, and you can see now it's in program, and we're still having the red color over there because it's not normal to have it like that. And we are going to go back to remote, but because you are in program, the key switch will continue in program, so we just keep tripping the program trip in this case. And then we have the local. And now I'm going to change it to remote because I want to change the limit values, right? So I'm doing it inside from the engineering station. I'm changing that. I have the remote. My alarm will change to remote, and then we keep having the sensor as red. So now we need to change the limits. So I'm going to change the limits for the hearer, and the hearer is, and once I change those values, we will have an alarm. So I'm also changing the limits for the valve. Those limits are to open and close the valve. So if you have a heater and then you need to cool down the oil and you don't do it in the time that you need it, you will have like problems depending on the process. So we are changing this one, and then once we accept it, it takes a little while, but it will show the alarms. And another thing is that, for example, in the valve, I changed both limits. So you don't want to show them that maximal and minimal. So you just create one alarm that it says both limits have been changed. So the less alarm, it's better to have it for the operators. And the things that they can also be relevant. And I'm just showing how the blocks are working and the limitations that you have. Now I'm just going back to the values because you cannot get rid of that without getting back to what you have hard-coded. Okay, it takes a little while. So now it's changing that, and we are going to have now the actual memory. So I'm sorry, we are going to display the firmware. I did some kind of simulation in this case because I didn't want to change my firmware. So I just have the alarm from there. Once I hit the simulation firmware, I'm receiving back the value to my PLC, and then I'm just checking that. And you have to acknowledge that firmware. You have to observe what was the changes and things like that. But once you have changed your firmware, you cannot go back to the one that you had it before. And now I'm going to just check the memory. So in this case, if I am beyond that memory that you need into your PLC, then it's when it's going to trigger the alarm. And then we have this is the logs, and it is going to copy what are the logs to the buffer, and then you will have the information in there, and we create the socket. And that goes to text or Excel file, and then from there you can take it from other places. The takeaways that we have it is, so create security functions, but don't mix them with operations. It is very important that you also have separate them, because it is also easy for the automation engineers to create them, to test it, and also to do the commissioning. And create the libraries. It's very important that you create always libraries and just generate the parameterizations and use what you have already in the PLC. There are a lot of tools that you can already use them. And of course, this is just a PLC, so don't expect that it's going to be doing some security stuff. So you have to create another detections. You have to have also this is just part of the defense in depth. This is just a detection that we created to have the operations more informed. So, yeah. And this is the reference that I use it. So we have the Logix 5000, of course, all the manuals for Rockwell. We have the top 20 security coding practices. We create a blog for the key switch. And then we have the logic controllers information and status. That one is the one that it includes all the tools. And thank you so much. So if you have any questions. Thank you. So, do you have any questions?
Thank you. This is very good. This is what I was hoping was going to happen when I made this presentation 2 years ago. I have a question. The display you were showing up there, was that not embedded so we see what was going on? Would a regular PLC programmer see that display with all the security stuff in there, or were you just doing that so we could see what was going on?
You mean on the demo? Or?
On the demo, yes.
So that one is actually the block that we created. Mm-hmm. The logic is embedded. So you have from your main function, and it is everything, all the logic is inside of that. So what you are seeing is just the alarm triggering. Right,
but that's not when it's been embedded. That's when it's been that's when you're showing it so we can see what's going on. Is that what you're doing? Or did you actually embed it so that it doesn't display with the regular code? Because there's a way to do that with Rockwell.
Yes, that is the AOI actually. So I can. Not to the video, but I can maybe go back. Let me see if I can go back. So those ones are already the AOIs. Inside of these ones, you have the logic.
So the security in the tree, would that be normally hidden using your embedded mode? Or is that supposed to be there invisible?
This one is not going to be invisible. You have it already there. That is, inside of this one, you have a logic.
Okay.
Yes. And this is created. You can put those. I wanted to put these ones out just to show you, but you can also put it inside of the logic.
That was my question. Yes.
Yes.
Okay.
Yes.
Thank you.
Yes, you're welcome. Any other question?
Hi, I just had a quick question. In regards to, you had mentioned in the takeaway section that create other detections. Is there, other than like the typical like C2 traffic or any type of beaconing activity, is there any specific, I guess, other type of detections you would recommend on creating for, I guess, to monitor this type of traffic to assist with monitoring?
So we are not checking what it is on the traffic, because that will be like a network IDS. We are creating some kind of low host IDS, so we want to check just what it is in the processor and what you can see in there. So it's mainly that. The only one that we have, and we are like testing it, is the one that you have from the message, and then you can see some active connections, but you create a set baseline from that one.
Got it. Okay, thank
Yep,
you.
you're welcome.